Hi guys. So now in this video I'm going to talk about some very relatively simple and straightforward applications of Gauss's law, right? So just to summarize, what is Gauss's law? So Gauss's law says that integral over a closed surface E dot ds, right, is equal to Q internal upon epsilon naught, right? So what does it mean? Basically it means that if I take the dot product of E dot ds, so ds is, so it's like ds is just a small area element, take a dot product and then sum it up over a whole surface. So let us say there is some surface like this, right? It could be any surface, it's a closed surface, that's a key thing, right? It's a closed surface. Inside that there is some charge, and it may not be one, they can be like, multiple charges. You can have one charge here, one charge here. This could be Q1, this could be Q2, Q3, right? There could be lots of charges. So Q internal, Q internal is the sum total of all the charges. So this is nothing but Q1 plus Q2 plus Q3 and so on, right? So integral E dot ds over the closed surface is equal to Q internal upon epsilon naught. This is what the Gauss's law says. Now, we'll discuss a few simple applications of this law, and we'll see how it makes problem solving very easy in some cases, especially where the distribution of charge is symmetric. Very shortly you'll see what I mean. So let us take the first example, okay? So the first example I'll take is, so let's say let us say an infinite wire, right? So there is an infinitely long wire, right? And there is some charge on this, right? By the way, I just drew the direction. It doesn't, just trying to show there is a wire. It doesn't mean there is anything flowing, right? So just a wire. In fact, if you prefer, I can just take it off. So this is just a wire, okay? And now you are told that there is some charge on it, right? Now how much charge? Right? It's infinitely long, so the charge is going to be infinity. So we'll talk about charge per unit length. Okay, we'll talk about charge per unit length, and let's say that is given as lambda. Lambda is my charge, right? Charge per upon length. Okay, so this is given as lambda, right? So that is lambda, and the question is now, let us say if I want to find the electric field at a particular point. So let us say I want to find the electric field at this point, right? And this point is, let us say, distance r from here. The perpendicular distance of this point is r, right? This is r. The question is, what is the electric field going to be? E will be equal to how much? This is a question, okay? So now, we could solve it without Gauss's law also. So we can take like, small elements and then find the field and then, then apply some logic and figure out the total electric field, but it will be a little painful. So here this will give us a very, very quick and easy way of doing it. So how is that, right? So this is a question. Now I would like you to actually, what I'll do is I'll give you a minute or so, right? Maybe 2 minutes to work on this problem, right? And see if you can use this to solve this, and then come back and we'll discuss the solution in the coming video. Thank you.